Hello, here's an example of how to solve a titration type problem. In this case, we are titrating an acid with a base. So it says it takes 83 milliliters of 0.45 molar solution of sodium hydroxide. So this here is our base information to neutralize 235 milliliters of a hydrochloric acid solution. So we know the volume, but we don't know the concentration. That is unknown. So what is the concentration of the hydrochloric acid solution? For these kinds of problems, you want to utilize a useful equation that the molarity of a substance, capital M, times its volume will give us the number of moles of that substance. And this comes from the fact that our definition of molarity is that molarity is a ratio of number of moles of a substance per liter. So if I multiply that by the liters of the substance, which is over 1, my units of liters cancel and I'm left with just my answer in moles, based on the definition of this ratio. Okay, so in this case, we titrate an acid with a base. So if you were setting this up in this particular problem, you have your ring stand here. You have your little device to hold onto the burette. That looked like this. You have your burette right here. And then you have the base that goes inside of it. So this has your sodium hydroxide. It's in the burette, and it drips down here into my flask. And inside the flask, I have my acid. Okay, so as I add this sodium hydroxide to the acid, it is going to neutralize it. And it's going to neutralize it according to our equation that an acid provides hydrogen ions in solution. If I react that with a hydroxide, that, at least according to one definition, produces hydroxide ions in solution. Here's my base. They will neutralize and they will form water. If you remember that water has a pH of 7, pure water, and so as we add this, we're going to slowly neutralize the acid until we've added enough base where it is totally gone. So we have this data. We want to know what's the concentration given my information. So if I go back to my equation here, and I apply that just to my base. So my base, I know both pieces of information. I know its concentration is 0.45 moles. Excuse me. That's the molarity, so it's my ratio. And I know that my volume is 83 milliliters. Well, remember in my definition of molarity, it's moles per liter. So I've got to turn 83 milliliters into liters. So what is that? Well, it's 83 divided by 1,000. So to multiply by liters, I've got to multiply it by 0.083 liters over 1. And what that will do, that will cancel out, and liters will cancel, and I could rewrite this. We might as well do that here. I can, there we go. Erase that and rewrite this as being moles per liter. That's the same value, but just rewriting it in a different way. My liters cancels, and I'm left with this answer. So 0.45 times 0.083. You can double check this, but it's 0.037. We'll round it there. And what's the unit? Always include that. It's moles of what? It's moles of my base, which was sodium hydroxide. So I know that I've added this much sodium hydroxide in order to neutralize my base. Excuse me. I've added this much base to neutralize my acid. That's how much it took. And how do we tell that again? If you remember from our lab, we saw the color change. It went from being clear to being just slightly pink, purple color. Okay, so we know that that's how much that I needed to neutralize. So this was needed to neutralize. Now, if I take that sodium hydroxide and I then match it with my acid, it should be the same because the molarity of my acid times the volume of the acid that was there should equal the number of moles of my acid, which should also equal the number of moles of my base. why is that? Well, if you look back at our reaction over here, this one, we reacted 1 hydrogen ion, that's for my acid, for every 1 hydroxide. So there's a 1-to-1 ratio. What I'm saying here is this is the mole ratio between these two things. So I know the number of moles of base. That's my 0.037 mole. Therefore, that's the same thing as how much acid must have been present. 0.037 mole. So I look back to my problem. I was being asked to find something. I was asked to find what is the concentration of my hydrochloric acid solution. I know its volume. It's right there, 235. So if I want to figure out its molarity, I've got to figure out that it has 0.235 liters. That's just converting 235 milliliters into liters. And I need to know and want to know its molarity. So I'm left with this equation right here. Concentration times the volume in liters equals the number of moles. I know 2 of them, and I can solve for the other. So I'm going to take 0.037 divided by 0.235, and you get your concentration of your molarity equals 0.157 molar. Or we can write that as 0.157 moles of acid per liter of solution. So that is how you solve that type of problem.